the SQL analytics endpoint of the lakehouse. So SQL analytics endpoint of the lakehouse acts as a database for the developers to analyze their data. So the one aspect or the one limitation with respect to the SQL analytics endpoint is it's a read-only endpoint, meaning you cannot create new tables or alter the data within the table. So it's a read-only aspect. Since it's a read-only aspect, you cannot execute DML statements or create table statements, but you can execute select queries on the tables. Since you can execute select queries on the tables, you can create views, functions, or stored procedures that can be used for query execution purpose, not to insert or for any DML purpose. Then we saw the collation aspect. By default, there is no the collation of the SQL analytics endpoint is binary, meaning it's case sensitive and accent sensitive, and there is no way for us to modify the collation of the SQL analytics endpoint. Though there are two types of collations that are supported within the SQL analytics endpoint. Then what is the second collation used for? It can be used for expression level collations that we'll take a look eventually in upcoming sessions. So that is with respect to the collation aspect. Then we identify different options within this SQL analytics endpoints with respect to how we can enable those tables in how to connect the SQL analytics endpoint via the SSMS and other aspects, except endorsement. Endorsement is a data governance aspect that we would cover eventually. Now, up till now, we saw that one way to load the data into the lakehouse tables is via the structured files, and within structured files only delimited and Parquet files are supported to be loaded. Parquet files are supported, which supports this functionality to load the data to tables in the lakehouse. So that's the one aspect that we saw up till now that allows us to load the data into the tables. Does that mean this is the only option? The answer to that is no. If you all remember, when we were allowed to create new items, there we had multiple options to get the data. It's via data pipeline, data flow gen 2, event stream, and notebooks. So it's via these set of objects also that we can load the data into the table within the lakehouse. So that's where this option comes in, wherein if you want to get data within the lakehouse, you can upload the files into the file structure, or you can use data pipeline, data flow gen 2, and event stream, and even notebook, open notebook, to load the data either into the file section or the table section within the lakehouse. That we would cover eventually when we would actually cover across all the major components with respect to data pipelines, data flows, and notebooks. Now, one aspect is you can upload a file into the file section, but you cannot download a file, unlike Azure Blob Storage. So in case if anyone has to download the file, how can one download it? The answer for that is there is something called as Azure Storage Explorer, Microsoft Azure Storage Explorer, that we would cover eventually in subsequent session once we by next week, once we take a look with respect to Fabric Warehouse as well. So now let's come to today's agenda. So we saw that in the backend, the tables are preserved in the underlying format of Delta Parquet files. And what do we mean by Delta Parquet files? In case of Delta Parquet, we get the Parquet file is like the main database file equivalent to the SQL server. That is, it contains all the data, whereas the delta log files are the transactional files equivalent to the LDF file, the log database file in the SQL server. It contains the different transactions that have happened across and at what time, and what is the path that contains that corresponding Parquet file. So it is because of this functionality or because of this feature of Delta Parquet that one can go back in time and identify what is the scope of the data at that time. What do I mean by that? So basically, in today's world of data engineering, correct, it is not enough to store your, it is not just enough to store your data. There are multiple requirements that comes in, like you must trace back your changes, recover past states, and support reproducible analytics. So those aspects, Microsoft Fabric Lakehouse basically provides exactly that, these aspects like recovering past states, tracking changes with the concept of time travel on delta tables. Now, what do we mean by time travel? So time travel in Microsoft Fabric allows one to query and restore the data from a previous point in time using the Delta Lake technology. Now, what is the Delta Lake technology? Wherein we have the log transaction files that provides us different instances at which there were different transactions that has transpired. So one can state that time travel lets you query previous version of the Delta table at any point using either a timestamp or a version number. And we'll take a look as to what I mean by either a timestamp or a version number. Now imagine that if you have the flexibility to go back in time and identify the state of the data as of that time, the benefits behind it. It's like having a rewind button for your data, correct? Imagine you accidentally deleted certain rows. You want to roll back. You have the time travel functionality. Imagine you need historical analysis rather than preserving snapshot on a daily basis, correct? You can query the old versions of the data. You can undo your set of mistakes, like accidentally deleting rows, updating rows, overwriting, and having data compliance, governance and compliance, wherein in case there are any needs, you can backtrack and identify the data as of that instance. So let's take the practical look with respect to our time travel functionality. So now we saw that it is possible to load data into the tables, not only via the files, but there are different options which are via get data or via the notebook aspect. So in this session, for the demo purpose of time travel, I'll be leveraging the notebook functionality. But do remember that notebook would be covered in detail eventually in the subsequent sessions. But for now, let me go to the notebook. So I have a different workspace called optimization. In that, I already have created a lake house called Lake. This is my lake house. And as of now, there is no data within the lake house, either in the tables, neither in the tables nor in the files. So now what I have done is I have created a notebook and I have mounted the lake house to that notebook. What I'll cover this notebook in detail, but to understand the current scope of scenario, what do I mean by mounting the lake house to the notebook? Correct. Whatever query I am executing here, correct? There are two aspects how I can do that. One is in the notebook, in the initial stage itself, I can write a code wherein I'll be connecting to some destination at runtime. So in that case, dynamically, I can change which destination it is trying to connect to. But in that case, there would be some amount of time that would be executed or leveraged in order to connect, authenticate, and connect to that corresponding destination. Because first I'll have to authenticate, then I'll have to authorize and then connect to the destination. So unnecessarily, there is some amount of time that is getting leveraged while trying to authenticate and authorize. But in case if I'm very sure that I want to connect to that destination itself, I do not want it dynamic. So at that time, there is an option wherein you can mount your corresponding object into the for that corresponding notebook. So in that case, whatever executions are happening, it would happen on that corresponding data destination itself. In that way, we are avoiding the code, the capacity and the time that is being leveraged in order to connect to that particular destination. What I mean by that? If you see here, in the Explorer aspect under data items, I can add existing a new lakehouse or the existing data sources. In the existing data sources, I can add the corresponding lakehouses on which I want to execute my corresponding code. This is what we mean by mounting your data item to the corresponding notebook. So all instances of this code that is getting executed would be executed on this lakehouse itself that has been mounted. So it's like hard coding your connection string, wherein you are hard coding that this notebook code needs to be executed in this lakehouse itself. Making dynamic metadata driven aspect, we will take a look once we actually want to work on the notebook aspect. For now, just to understand that I have mounted my corresponding lakehouse that is empty to my corresponding notebook. Now, the notebook allows us to execute code in multiple languages. If you see the drop down here or here, you would see that there are different options. I can execute HTML scripts. I can execute R scripts. I can execute Spark SQL, or I can execute Scala, and I can execute Python. So those who are familiar with Azure Databricks can consider Notebook as similar to Azure Databricks itself. Or those who have worked on Synapse Notebook can consider the Fabric Notebook somewhat similar to that. So here, this %% indicates a magic command. And that magic command is to change the language here. I can select a drop down. Imagine that if I select PySpark, can you see the magic command disappeared? If I select Scala, %% Spark. So rather than manually drop downing and selecting the corresponding language, I can write in a code and automatically the drop down would get updated. So here I am stating that I want to execute my code in Spark SQL. Since I'm much more familiar with SQL, normal SQL aspect, I leverage Spark SQL version, wherein I have to execute the commands majorly via SQL statement itself, which is my core strength. So now I am connecting to this lakehouse and executing the query of creating a table. Now, if you see, this is a normal create table that I had executed, correct? Create table, C1 integer, C2 string. Now, here, I have commented using delta part. Because irrespective of whether you create a table using delta or without delta, the underlying table gets created in the form of delta format itself. So even if I execute this statement, it would go and create a delta table itself with or without me having to use this keyword. So now let me go ahead and execute this query. Now, since I'm executing this query for the first time, it would take some time for my session to start. And now it's executing this. Remember, notebook would be covered in detail, but for now, in order to understand some of the basic aspects, I'm even explaining some of the notebook aspect. This would be covered again in detail. So now the table got created. Now let's go and verify under the table section. Let me refresh this. Let me click on the tables. You all can see, correct? I have a TT table that I created. TT table. Now let me go and check the underlying file. You can see that there is no Parquet file. There is only delta log file. Why there is no Parquet file? Because as of now, I have not added any data within the table, correct? And Parquet files are only for the data aspect, whereas log files are for the delta aspect is for the log transactional aspect. And there was one transaction that got created for which the initial JSON file got created. That is the create table. I created the corresponding table. So now let me go ahead and delete this corresponding table. Now, if I remove this using delta aspect and if I execute this, it would again go and create the same table itself. Now the creation of table was quick because this session was already active. I need not start the session. So now the table got created again. But similar to the initial case, there is no data within the table, hence there is no Parquet file associated with that. And again, I can check that it's a create table aspect. Now, let me go ahead and insert certain rows into the table. So for that, what we do in the normal SQL aspect, insert into table, select or values. So in this case, I am inserting into this table 2 rows. Now, since I have added a semicolon, it is considering it as a 2 separate transaction. Since it's a separate transaction, what would happen is it would create 2 separate files. What I mean by that. Now, in case if I click to the Lakehouse front view, I'll be able to see 2 rows. 1 Hello World 1, 2 Hello World 2. One Hello World 1, 2 Hello World 2. Now let's go and understand the backend files. Let me order it by. So this was the first data that got inserted. One Hello World. Now the second Parquet file, that is, the second Parquet file would be 2 Hello World 2. But the overall table contains 2 rows, but the Parquet files are present individually because 2 rows were inserted separately. So now in case if I go to the delta log folder, I'll be able to see 2 JSON files added. One is JSON1 that indicates that it was a write operation and it added this corresponding Parquet file. And as of now, these are the minimum and maximum values, meaning the metadata that is present. Now, once I added the second file, it is also a write operation and it added a new file in the path, which is referencing this corresponding value, the corresponding Parquet. And it has its own set of minimum and maximum values. Now, let's go and take a look with respect to the time travel aspect. Now, in order for me to understand what are the different transactions that have transpired within that corresponding lakehouse table, there is a query called describe history table name. TT is the table name that I have created within this lakehouse. So the describe history table name, in case if I execute it, it provides me the different log transactions that have transpired, meaning corresponding to the JSON files that were present, correct? There were 3 JSON files. I'll be able to see 3 rows because these were the different logs or history that have transpired. So this query basically references the log files within the Delta folder. So now if you see, I have 3 versions, version 0, version 1, version 2, and the corresponding timestamp for the corresponding log files. The first log file that was present, the version 0, JSON 0000, that had create table operation. And then the subsequent versions of 1 and 2 had write operations. So these are the different histories that one can capture. Now, in case if I execute this query again, I'll see 5 different rows because 2 new additional rows got added or 2 new additional log files got created. So now in case if I execute this, 2 new rows got inserted because correspondingly 2 new log files got inserted. And those were also write operation. Now, I want to identify what is the data in the overall table. So for that, similar to how we had executed select star from the table name in the SQL analytics endpoint, I'm executing the SQL queries itself. So I'm seeing there are 4 rows because I executed that insert statement 2 times. So there are 4 rows that are present here. Now imagine that I want what was the state of my data as of version 1. So it's via either version or via timestamp. I can time travel back to that instance. So in that case, let's say that I want to check what was the state of my table as of version 1. Correct. So for that, it's the same command, that is select star from table version as of that corresponding instance that you want to query back. So now when I'm executing this query, as of version 1, there was only 1 row that had got added, correct? That is 0. That is the row 1 in the JSON 001. So for that, I'm able to correspondingly time travel to that instance itself. Now imagine I want to time travel to version 0. Version 0 is when there was no data present. It was a create table aspect. Hence, I'm not able to see any rows here. Similarly, depending upon the different versions, I can go back to that corresponding time and identify the data snapshot as of that instance. So version 2, it is both the rows got inserted. Now what would happen if I have a version number that is greater than any of the version that is already present? The maximum version that is present as of now is version 4. Sorry, correct, the version 4, correct. But now I am executing version as of 10. Would it execute? No, because it states that in this array, version is available from 0 till 4 only, not beyond that. Hence, it would fail. Hence, first step for you all to identify via describe history is to get the latest version if you want the latest state of the data. But in case if you want the latest state of the data, is there a need of executing version you can execute normal select star from the corresponding table itself. That would give you the latest data, which is equivalent to the version as of the latest data as of the latest version itself. That is, let's say version 4. So query as of the latest version is similar to executing this query itself because it provides you the latest state of the data itself. So now we identified a way to to check the data as of the timestamp version. Sorry, as of the version aspect. Now imagine that if I want to check the data as of the corresponding timestamp. So let me copy this timestamp. Now, if you all see, I copied the timestamp as of this instance, as of version 1. But there is a catch here, unlike version here. So for identifying the data as of that timestamp, similar to version, rather than version, it is timestamp as of. So now when I'm executing this query, unlike version, if you'll see the timestamp as of, I took the timestamp as of version 1, but it is showing me 0 data, state as of version 0. It is because the log file got created at that time, but the data file gets created eventually. So at that time, there was no data present. So it is always n-1 with respect to the timestamp and versioning. So the timestamp in version 1 provides me data as of this instance itself. So now if I copy this timestamp, it would give me data as of version 1 itself. So now I'll be able to see only one row. So via timestamp, it means the data as of that timestamp and prior was this one. Now, is it possible for me to identify data timestamp? Okay, I'll give a case study later. So now we were able to see that I'm able to time travel back via either the versioning aspect or via the timestamp aspect. This is what I meant with respect to time travel lets you query previous version of delta table at any point using either a timestamp or a version number. This is what is time travel functionality. Now, let's take a scenario wherein imagine that I want to create a new table or a backup table as of that particular version. So in that case, I can use it. I can create or replace a table. In case if this table already exists, I'll replace it, else I'll create it. Unlike a blank create statement, I'll be creating or replacing that table as select star from this version as of. So I want to have a backup table that has the data as of version 1. So I can restore the data as to that previous versions and manage my backups. So now I'm able to query that restore table and I'm able to see that one row got returned. This is the concept of time travel. Any queries up till now on the concept of time travel? So a pretty simple way to go back to your data. And remember, this concept is not only specific for Fabric. This is present across multiple locations. Why? Because of the concept of delta parquet. It's based on those delta files that one is able to identify the different transactions that have happened and accordingly go back to that corresponding version and the transaction file, which in turn points us to the corresponding parquet file for the data aspect. So this is time travel. So any queries on time
This
travel?
you will require only if you have to restore tables or something like that, right? Like this feature, time travel.
It's to restore feature, or imagine that I mistakenly updated or deleted certain records.
Okay.
Correct. If
Hmm.
that is the case, then I want to restore it to the state as of that time. Correct. So I can go back to that
Rollback.
particular version.
Ah,
So it is what we call as rollback, that I am
ah,
rolling back from the current state to the previous state.
ah.
Or the main aspect in today's data world is analysis. Correct. Now imagine that I want a daily, I have a latest version of the data. Correct. But I want to go back as to check what was my age as of that day. Correct. So rather than preserving the snapshot on a day by day basis, I can use time travel and check the data as of that time. I need not preserve the data as a snapshot table and duplicate that data because that is already being present in the form of delta per itself.
And is this the only way to roll back, like in PaaS or even on our on-prem, like you have checkpoints, you can go to that checkpoint and Microsoft takes care of taking the backups and we can take that checkpoint to roll back. So is
This
that
is a
feature
lake house.
available?
In
Oh,
case
it's
of
not.
Azure Blob Storage, this is a data lake. In Azure
Ah,
Blob, you are talking about the database equivalent. Correct. In case of
oh,
database,
okay.
you have backup points. This is not a database. This is a
Okay,
data
got
lake.
it.
In Azure Blob Storage, you do not have that functionality. It's here only that via this time travel aspect that you can roll back in time.
Got it. Got it.
Now my question is, in case if I drop a table, would I be able to restore it back via the concept of time travel?
Sorry, come again, Nandan.
My question is,
Uh-huh.
in case if I drop the corresponding table or
Yes,
delete the table, would I
yes.
be able to restore this table back via time travel? Yes or
I think
no?
yes, because we have like delta metadata in data tables. So using that, I think we can restore.
What about others?
Drop table, right?
Nanda, see,
No,
No,
every
I think
every file has only that change that is there in that file, right? Like if I do four changes, I will have four files.
I'll come to that concept a little bit later. I'll come to
Okay.
that. Hold on to that.
I was just thinking from drop, if it is to drop and then recreate, then which file it will read. Yeah. Okay. No, I think no, not possible.
So who all say it is possible? Raise your hands.
not possible because all files will also get deleted.
See, let me delete this. Once I delete this, do you see any delta parquet files here? On what basis is the time travel happening? It is happening based on the delta parquet files. Correct. But once I delete the table, it means I'm deleting the underlying files that is associated with that tables. Correct. So now imagine that if I want to execute describe history TT, the table or view cannot be found because I do not have that corresponding object in my lakehouse because the corresponding files associated with that gets dropped or deleted once we delete that table.
So
So if that
delta
is
lake is delta log is also deleted, right?
everything is deleted.
Okay.
It's an empty aspect. If everything is deleted, then is it possible for me to time travel back? Yes or no?
No, no.
no.
So it is not possible for me to time travel back. That we all agree. Correct. My question is it possible for me to restore back that dropped table?
And then the functionality should be there somewhere, but here with the help of TimeTravel, it's not possible.
Perfect. So do remember that it is possible for me to recover that deleted or the dropped table via some other aspects, but it is not possible via this concept of time travel, because for time travel the corresponding delta Parquet files are no longer present. We'll take a look with respect to how to recover back a deleted table in the lakehouse once we cover the core concept of notebooks. For now, that's an advanced concept that I'll put a hold on to that. But just to have your thought oriented, I hope you all understood, correct? Why it is not possible to time travel? Because you don't have the underlying delta Parquet files. Because once you delete the table, the files associated with that gets deleted or dropped. Am I clear?
Yes.
Yes. Yes.
And
Uh,
as Krishna stated, it is possible to recover it back, but not via the concept of time travel. There is something called as a semantic pi library that you take a look once we actually deep dive into the world of notebooks.
One question I had, Nandan, on this, time travel or this type of concept. Is it possible that, like, if a my question is that if a table, if we are capturing every transaction in a table, and if the table is like getting updated frequently, then is it like really logical or to keep that much files, or is it space performance intensive? What is, why should we
Perfect.
do that? Yeah.
Perfect. That is the next aspect called optimization that I'll come to. Yesterday, if you all saw, under the lake house, there is for the tables, there is something called as maintenance. Correct? So it is this aspect that we will be covering now. A very good question. Correct. That's the aspect that as a data governance team, the admin is responsible for those aspects. And we'll take a look into those aspects now. But you are absolutely correct on on your question. But I'll come to that. But other than that aspect, is there any query on the concept of time travel? I guess that is pretty clear, correct, to everyone?
Yes, Nandan. So suppose you created a table, okay, and we do some operations, okay, and later on, suppose we change the schema of that table. So how will like we will handle? Suppose I have to read the previous version of.
So
So will it
that's the
give it
case.
error?
That's the case study, Ramesh, that I'll be providing today. If you saw, correct, yesterday I covered that. If you all remember in the structured files, what we had done is, so the case study I'll provide at the end. If you remember when I had provided a file, correct, structured files, sorry, in the existing table, there we had an option to use column header. Imagine that if the column header is something not enabled, then there were a new schema got created, correct? So create it from this aspect. For you all, there is no need to create it from the Python code or the PySpark notebooks, correct? You all can create it from here itself, correct? That is, upload a CSV file, load it as a table, then disable the checkbox of column. It would add the schema, correct? And then you would try executing time travel. For that, you need not execute from the notebook itself. You can also execute these queries from your corresponding SQL Analytics endpoint as well. Correct? So try executing this from the SQL Analytics endpoint and check whether you all are able to execute or not, and how it references the data. So I'll provide that in detail at the end of the session, the case study. Clear?
Okay.
You
Nandan,
all
one.
also,
Yeah, okay. Go ahead. Sorry.
no, you all also need to explore certain aspects so that it becomes a clear state of mind for you all. Anyhow, we'll discuss that case studies in the subsequent sessions. But rather than I covering each and every aspect, test it out yourself. And then we can discuss in the subsequent aspect. But a good question on that.
Yeah, thank you.
Yes, Krishna?
Yeah. And then what about the truncate statement? Will the timetable works for truncate?
Everything.
Okay.
Because as of that time, the data got deleted, correct? And then, yeah, as of previous time, since I'll come to that aspect, correct? Every transaction is being captured, correct? Since every transaction is being captured, the latest data as of now is 0. But time travel, there were different versions of that log file, right? As long as the log files exist, you can time travel to any instance and roll back to that previous instance itself. Everything is the major concept is on the basis of that log files and the corresponding Parquet file that is associated with that log file. Clear?
Yep.
So Nandan, in the case of only drop table, those file will get deleted, but in the case of truncate table, those file will not get deleted.
Truncate is a transaction that is happening. Drop is not a transaction. Drop is you're clearing up, and it's not just in the drop aspect. It's in some other aspect also that we would be cleaning up the log files and the Parquet files that we would see in the subsequent session.
Okay.
Clear? Now, one aspect that someone asked us, see, for every transaction, there are multiple, there are log files getting created. There are corresponding log files, and then there are corresponding Parquet files that are being present. Correct? So, imagine that every time, most of the organizations, frankly, do not work on historical data. They only want the latest state of the data. But in this case, since I want the latest state of the data, every time I am having unnecessarily log files and the Parquet files of previous states, which I do not need for my use case. But I'm still having to pay for the storage cost because of those log files and the Parquet files. Correct? Or let's say that in certain organization, that is a data governance aspect that I do not want to go back beyond 2 years in time. I want as of last year itself or last 2 years itself, not beyond that. So at that time, I do have the need of cleaning up all the previous versions of the files. And there are other aspects as well with respect to, okay, let me take one step back. If you all remember, let's think with respect to what is the benefit of the Parquet file over normal columnar file format. Correct? Let's remember the question. How much total sales amount was gathered by Maria Adams? Was my question. In case of normal columnar file format, I had to scan these two columns because it's the customer and the sales amount column that I'm concerned with. But I had to scan every row to identify where Maria Adams is. But in case of the Parquet file is a columnar format that stores data in the row groups. Correct? And I can see that Maria Adams is present in row group 2 and row group 3. Hence, I was able to skip one row group. Now, how did I skip that row group? Because of the metadata aspect that is present. Now, imagine that every time, whenever any tool has to read a Parquet file, the initial time goes into reading the metadata. Imagine that I have 100 different files. You saw, correct? When I inserted row 1, row 2, there were two Parquet files. Correct? There was no a union file of the both. There was one file with one row, another file with one row. Correct? So every file has its own metadata. every time I have to read the metadata and then scan across the corresponding data. So imagine I have hundreds of Parquet files with single rows. It's more time consuming, correct? Because unnecessarily I have to read the metadata 100 times. But what if I would have had only one file containing those 100 rows and a single metadata aspect? So at that time I had to read the metadata only once. That is what we call as optimization. So optimizing delta tables in your lakehouse in turn ensures that faster queries, better performance and efficient storage usage. Correct? Imagine that rather than having 100 and scanning 100 different files, I have to just scan one file. Isn't that much more performant, efficient, and in turn would provide me a faster query output? So for that, there are multiple maintenance methods that are available in Microsoft Fabric. First is something called as an optimize command. Now what the optimize command does is, it consolidates multiple small Parquet files into a large file, thereby improving the reading performance, because that single large file would have a metadata that can be read once rather than reading the metadata across different files multiple times. Then up till now, first aspect that we have done is reducing the files, multiple files into a single file. But to those who are new to the data engineering world, there is a concept called indexing in the data. Indexing in layman terminology is how are you actually ordering your, or what I can say, how you are actually arranging your data or ordering your data. So the indexing concept is similar to the V order and the Z order in the lakehouse. Now, to give a little bit context, who all here are not aware with respect to what indexing is? Okay, everyone is aware. Good. Okay. So now let's consider that in layman terminology, if I have to explain indexing, correct? Imagine that I am a data storage layer, correct? When I say data storage layer, consider I am a librarian, correct? Now, as a librarian, I am sitting on my desk and customers are coming to me and returning the book. Now imagine that someone came and returned to me one book. Now I took that book and directly threw in my location. Wasn't the data insertion quicker? Because I had to take that book and directly throw back. Imagine multiple folks come to me at the same time. I can directly take the book and throw back. Throw in a layer of stock. So the data insertion was pretty quick. But imagine the other way around. Someone wants a book, meaning I have to read the data rather than insert the data. So when I have to read the data, meaning imagine that someone says to me that I want the book on Harry Potter, of Harry Potter. At that time, since I had thrown all the books into a stock, I have to manually go across and search each and every book in the stock and check where the Harry Potter book is. Sometimes it can be at the top, sometimes it can be at the bottom. I do not know where it is. Correct? It's luck based, when I have to manually search across, and whenever I got it, I can extract it. So isn't my retrieval time increased significantly? Now imagine that if I have to improve my retrieval time, what I can do is I can have a rack, and in that rack I can order the books alphabetically. A, B, C. So in that case, this is what I'm physically or I'm particularly arranging my books or arranging the data in some order. That is what we call as indexing. Now imagine that if someone comes to me and says, provide me a book on Harry Potter, I can go to the rack, I can check H section and provide that book. So my data retrieval became much more quicker. But imagine that in case if someone provided me a book, now I have, rather than throwing the book into the aspect, I have to go to that corresponding rack and arrange that book in that particular section itself. So when you do indexing, your data retrieval becomes quicker, but your data ingestion becomes slower. Hence, now I arranged the books based on alphabet. But in alphabet also there would be multiple books with different authors. So now imagine that I have within H I have a big rack. I have one Harry Potter book in one section, one Harry Potter book in another row within that rack. Correct. I have to scan across Harry Potter books. So what I can do is I can add another sorting aspect, that is arrange the books alphabetically and by author. So all alphabets and corresponding J.K. Rowling's books would be in the similar aspect. So I can directly quickly now go and retrieve, but my data insertion would be much more slower. Now I have to first scan the alphabet and then search for the corresponding author and then place that book there. Hence, one has to be very careful while doing indexing. Indexing does support the data retrieval, but it has a bad performance impact on the data ingestion. So it's a balance that one has to keep. Hence, in order to improve performance, indexing should be your last of the option to proceed with, because your data ingestion time increases. So this is indexing in the normal terminologies. I hope now it is clear what I mean by indexing. So now, in the lakehouse, the concept of indexing happens with respect to the aspect of V order and Z order, vertical ordering and Z ordering. So V order applies optimized sorting, encoding, and compression to the delta to enable fast read operations across all the fabric engine. Pretty confusing terminology. Let me show you a visual representation of that as well. Or in detail explain V order and Z order in the subsequent time. The Z order is used to improve query performance by physically organizing the data in a way that reduces the amount of data scanned. Still confusing. Let's deep dive into V order and Z order in the subsequent aspect. And then comes the concept of vacuum. So vacuum removes the obsolete data files that are no longer referenced by the delta table. This helps in reclaiming the storage space and maintaining the overall table health. Answer to someone's query on, is there a need to maintain all those files? The answer is no, we can vacuum it out. And we'll take a look with respect to each of these maintenance methods in detail now. Now, before we go to optimize, let's understand the V order and Z order so that once we take the practical route, you will understand what is happening. Now, let's understand the problem statement behind this. Imagine that I am frequently running queries like select star from the sales data where sales data in this. Meaning I want to filter out specific subset of data. Now, in case if there is no Z order, Fabric would have to scan the entire table even if only 1% of the data is relevant. So in case of the solution for this would be, I can Z order the table by sales date and store location. So what it means is it organizes related rows together so that it can skip large chunks of data during queries, making them much faster. So in case of my normal analogy, bookshelf analog that I can consider, before Z orders, the book were randomly arranged. But now after Z order, I have arranged them or grouped the books together by date and location. Or to be more specific, in the previous example, I have grouped the books by alphabet and author. That is what we say Z ordering, because it is easy for me to retrieve it, filter out. If someone says I want Harry Potter book, now H and JK Rowling, I can easily filter out. This is Z order. Now V order is basically delta files. Let's understand the problem statement. Delta file stores column data in an inefficient layout, leading to larger files and slower reads. Now V order optimizes the column layout inside each Parquet delta file. Now by default, in the lakehouse, V order is enabled. So basically in layman terminology, V order reorders how the data is written to the disk, reducing the read time and the storage cost. In layman terminology, consider that you have a suitcase. You have randomly thrown your clothes within the suitcase. But that was before V order. But now after V order, meaning what does V order do? You efficiently have folded your clothes and arranged them efficiently. This is V order. Now, in case of visual representation, or one can consider V order as column level layout, because you are efficiently arranging this was haphazardly arranged randomly. Now I have properly folded the data in the respective aspect and have ordered them into proper files, optimized files. Z order is proper random aspect. I have properly arranged them in the proper filtering categories that I needed. So this is V order and Z order. These are the references that you all can leverage for understanding this concept. But now let's go to the practical aspect of the same. Now, let me open my notebook. Okay. So now again, you all can see that I have a notebook wherein I have mounted my corresponding lake house, the lake. As of now, there are no tables in the lake house. Okay, there is a table. Let me delete that. As of now, the lake house is empty. Now, if you'll see here, when I click on this table maintenance, there is something called as optimize. By default, optimize write is enabled, meaning while writing the data into the lake house, the notebook or this corresponding Spark session takes care of writing the data in the optimized write format itself. Since we want to see how to optimize it, hence for that I'll disable this property. So earlier I was using PySQL, Spark SQL. Now I am using PySpark. We'll be covering these aspects in detail notebook, but for now to understand, I'm just explaining what does this code signify here. So for this corresponding Spark session, for the corresponding Spark configuration, I'm setting this property that spark.microsoft.delta optimize.write enabled as false. So I'm making the default that was enabled true to false. So now the session started. And now it is making this property, that is optimize.write for delta tables, as disabled. Now let's go and validate. So spark.configuration.get, I'm getting the status of this corresponding property now. So it's false. Now I have opened another notebook and I'm executing this query. Now, correspondingly, there are two notebooks and every notebook is having its own separate session. You saw, correct? A session started, whereas a session was already active here as well. But for this second notebook, it started a separate session. We'll understand how to manage these sessions, etc. in the notebook aspect. But for now, just to understand that it had its own separate session. Now, in case if I try to get the property of this, try to get the value of this property in this session, it's true. It states that the delta dot optimize write dot enabled is true in this session. But in the corresponding earlier session, if I try to execute this, it is still false because for this session, I have disabled this property, whereas for the other session, it is still active because by default, that property is enabled. So now what we created is I disabled the optimize.write delta property within the corresponding session. Now, similar to earlier aspect, let me go ahead and create a table. So the table is getting created within the lakehouse now. So the table got created. Now, in case if I go to the table section, if I refresh it, I'll be able to see the test table that I created. In case if I go to view files, I'll be seeing the delta log file only. Now, let me execute this query wherein I'm inserting 5 rows within this corresponding tables. So now corresponding to these 5 rows, 5 different Parquet files and 5 different log files would get created. Any queries up till now? Okay.
The session you disabled, okay, for the current.
I didn't disable the session. I disabled that property within that
Yeah,
session.
properties. Yeah, I meant to say that. Okay. So when we open a new notebook, so I think it will by default it will be enabled that properties for different
By
notebook,
default,
right?
that property is enabled for every session, correct? Unless you explicitly do it. The default aspect is whenever a notebook is created, it has its own session.
Yes.
Now there is a property via which you can have a similar session across that would cover once we take a look with respect to notebooks in detail. For now, let's understand that this property is only specific to that session.
Okay.
Clear?
Yeah.
Now, in the lakehouse, the corresponding files got created. I can see 5 Parquet files and I can see 6 JSON files. One is the create and another is the 5 others are with respect to the corresponding write functionality. Now, if I check the file, every file is only a single row in itself. Correct? Hello world 5, hello world, okay, 4, etc. Correct? Now, in case if I execute this query, I'll see I am able to get 5 different rows. Now, let's understand the optimization aspect. Now, in case if I go to this and click on here, so there are 2 ways how you can optimize the data or execute the optimize command in the lakehouse. One is via the portal way, another is via the notebook or the coding way. For now, we'll check the portal way. So here you would go under maintenance. Under maintenance, you can see, correct? run the delta leak optimize command in Spark to compact. So I can execute this, and by default, it applies a V order as well, vertical ordering. So now in case if I execute this command now, what it would do is it would try to optimize all those smaller Parquet files into a larger Parquet file. Now, as per now the optimization aspect, is there a fixed size of Parquet that should be present? Correct? It depends on service provider to service provider. Now, Microsoft in their Synapse and this Fabric aspect suggests that 128 MB and above and below some corresponding value is an optimized value for having Parquet files. Correct? So now you all can see that some command is getting executed. The optimization command. It takes around 5 to 6 minutes for it to optimize it properly. Now, does that mean that, imagine that I have millions of single files? Does that mean that those millions of single file get created into a single Parquet file itself? No. Depending upon the amount of data, it might get split into multiple different larger Parquet files. Correct? As I said, there is some optimization aspect. So it does not combine the entire millions of rows into one single large Parquet file, because that also is not proper aspect. Correct? So it optimizes it into multiple chunks of larger Parquet files. But in our case, we only have 5 rows. 5 rows is not big data, correct? So those 5 rows would get converted into one single file once this optimize command gets executed. Now, once we execute the optimize command, see, the optimize command got successfully executed, correct? This is the front end view. Let me refresh this. It's refreshing, correct? And parallelly, let me go and execute the select all from the test table. It's still the same, 5 rows. Should I have got 5 rows? Yes, correct. Optimize command does not mean I should delete the data. Correct. I want the latest data to be present at any point of the time. Correct. So in this case, even though the optimize command got executed, I'm still able to see the latest data itself. That is 1, 2, 3, 4, 5. Agree? But now let me go and check the file section. You all can see that a new Parquet file got added at 9:10 a.m. All the other files, all the 5 files were created when I had inserted the rows, but now a new Parquet file got created. If I click on this Parquet file, it contains the union of all the small files. The data is the union of all the small files that is present together as a single Parquet file now. And now let me go to the Delta file here. So a new Delta file also got added. And here it is stating that now 2 files got added. One is optimized and another is V-order. Correct? Because we had enabled those two. So here I can see that there's an optimize aspect. In the optimize aspect, a new file got added. And then can you see remove path? Meaning now I have created a new file that is union of all the old files. And hence, whenever now I'm querying select star, it is excluding the old Parquet files because now they are under remove section. Meaning these paths are no longer needed because the union of all the data is now present in this single file that has been added. So in optimized aspect, it creates a new file. Now there can be multiple add files. Similar to how there are multiple remove files, there could have been multiple add files. Considering if the data have been in millions, it would have created multiple large Parquet files. But in our case, since the data was very less, it created a single file and it added the corresponding path and it removed all the previous link. This is what optimize does. But if you all see that the old log files are still present. The old, and this is with respect to V-order. We auto set V-order table property and we V-ordered it. Now, if you see the old delta files are also present and Parquet files are also present. Correct. Why those are present? Imagine that if I want to time travel back as of that instance, because this gives me union of all the data across all historical data. Correct. That has been present. But imagine that if I want to time travel back, I cannot time travel back based on this latest file and the latest log file, right? Because it contains a single transaction that is optimized. So in order for me to time travel back, I still need the old version of Parquet files and the corresponding log files. Any queries up till now?
Now after this, if you add a new record, will that file be having a single record or it will have 6 records?
What is your thought?
I think it will be 6 because that property is set.
Let me go to, let me create a new layer. Let me insert 2 rows. Since these are 2 separate aspects, now in case if I refresh this, I'll see 2 new rows got added and the corresponding 2 files. Why didn't additional rows got inserted? Insert into test. If you all can see here, 2 additional files got added with single rows. But now let's go and check the log file here. So basically what happens is, and can you see by default the V order is true when you write, because it's a default aspect. When you write any code, it automatically orders it in the V order itself. Now, because since this is a separate transaction, the Parquet file was already created, correct? It does not merge into existing Parquet files when you write anything, correct? Every write aspect creates a separate Parquet files. But the optimize command, what it does, it scans across all the values that are active files. What I mean by active files, if you remember, there was an add file path and remove file path. So it checks across. Now, whenever you are querying any data, it goes across the log files and checks all the add file aspect, the add path, meaning it is this path files that I need to take and provide a union of the data. Unlike remove path. So in remove path, I need to meaning exclude these JSON files. Now, in case if I execute the optimize command again, then it would again create a single file with the union of all the data. But once a Parquet file is already created, it does not mean it would go and update that existing Parquet file. Imagine that even if the write delta.optimize write is enabled, imagine I'm just inserting 2 rows, it would still create a new Parquet itself, because it cannot go and append or update the original Parquet file. Because if I go and update the original Parquet file itself, I won't be able to time travel, correct? Because for every log, there's a corresponding transaction file that gets referenced.
Got it.
So now, I hope you all understood the concept of optimization, correct? Now, it got created a single modular file. Now, let me go ahead and optimize this. Now remember that once a table is V order, I can Z order it again because both are different ordering. Correct? So a single table can have V order as well as Z order. Now let me optimize this table and Z order it by C2 column. Or let me Z order it by C1 column. This would again try to optimize the lake. So one way for us to optimize and V order is via the portal itself. And you can also execute optimize lake. And if you don't want Z order, you can split it. This by default ensure it is V order itself. So now let me go ahead and refresh this. Now you can see that there is an optimize command that got executed. Similarly, a new Parquet file would have been created. And now this Parquet file contains a union of all the data that got executed. And in the latest optimization aspect, you all would see that if you all remember, three new Parquet files were created, correct? The previous optimize command and the two new Parquet corresponding to the individual rows. So now it created a single file and removed the references to the previous three Parquet files. This is optimization. So any queries on the concept of optimization, V order and Z order? So I can optimize, and if I execute this, it means it's optimizing with V order, which is the same. Any queries up till now? I'll take it as a no. Now, the next aspect is the question, how to get rid of the old files that I do not need, correct? So for that, there is an option called vacuum. So now, in vacuum via the portal aspect, run the delta leak vacuum command in Spark to remove files that are no longer referenced and that are older than the retention threshold that you set below. Imagine that I do not want to time travel back beyond 7 days or 15 days, etc. Correct? So at that time, I can have this property enabled. 7 or let's say after 15 days or after 365 days, year, correct? Depending upon the data governance time that your organization sets. Can I reduce it to 1? No. It must be 7 days or more in case if I have to execute it from the portal. But has my data been reduced beyond 7 days? No, correct? Because I have executed everything up till now itself. Correct? That is today only. So then does that mean that I have to show this demo of vacuum command to you all after 1 week because 7 days is the minimum aspect? The answer to that is no. From the portal, the minimum date is 7 days. And you set the 7 days and execute run now, it would vacuum it for the files that are prior to 7 days. But since we created all the files today itself, none of the files would be vacuumed or deleted. So for that, we would leverage the concept of notebooks. So in notebook, I can execute a command called vacuum table and retain last, let's say 1 hour of data. Correct? Now, in case if I execute this, it would fail. Let's read the error message. Correct? It is asking that, are you sure you would like to vacuum files with such a low retention period? If yes, then I have to disable this property first. So for that, I'll go ahead and set this property as false, meaning I'll disable this property. That is databricks.delta.retention duration check.enabled, meaning this property ensures that below 7 days should not be deleted. But I'm disabling this property now. So once I disable this property, I can even vacuum 0 hours, meaning do not have anything beyond now. Only keep the latest set of data. So now once I execute this vacuum command, it would go ahead and clear the Parquet files that are being present there. So now the command got executed. Now let's go and take back a look with respect to the file. The log files are still present, but can you see the Parquet file got reduced to a single file? Does that mean the log files do not get deleted? The log files can also be cleaned up, but for that the vacuum basically cleans the major. Log files are transaction files. They hardly have any data present across. Size of the files is bare minimal. Correct? Even if I have millions of files, it would hardly lead to 1 MB. But it's the Parquet files that is actually your data files. Correct? That would contain significant amount of data. So the vacuum goes and cleans up the Parquet files. Now you all can see, correct? I had multiple Parquet files. Now that has got reduced to one Parquet file itself. Now in case if I go to the log folder, I'll see that a vacuum command has been executed. Now, even if I go to this log file, which is mapping to this path, Parquet, there is no corresponding Parquet file that is present here. Hence, once I execute the vacuum command, it deletes the previous references of the Parquet files that were created beyond that time and only preserves the latest file. And since the Parquet files are no longer present, I cannot time travel back to that instance. Hence, once you execute the vacuum command, you cannot time travel beyond that vacuum time period. Since I executed 0 hours, all the old files got deleted and I only have the latest version of the file. Latest active versions of files. Imagine there were 3 active versions, there would have been 3 files. So this is vacuum. Vacuum helps me to clean up the unnecessary files that are no longer needed, which in turn helps the storage aspect. Any queries up till now? Okay, I'll take it as a no then. So